Okay, you see my screen or no?
We were actually seeing even before.
Yeah, you can see, but it's not broadcast, is not happening, so it may not be recorded. That's why he reminded. That's good. Thanks for the reminder. Yeah. So mainly here, the cost scenario we are trying to analyze. The two scenarios we're going to analyze. The same scenario, if you see here, the scenario one for this 300 writes per second, 2 MB object size, and 1 terabyte per month, and this many objects per month. If you want to store this type of scenario storage, S3 storage will cost you, storage wise, it's only $44, right? It's very small. And but the request throughput, like putting the data inside and taking the data outside for S3, that request number of requests costs 3,888. The total is like 3,932. So if you see if you go with this solution, S3 solution as a storage solution, this will cost you this much for the scenario. Same with if you go with DynamoDB, the DynamoDB calculation is different for the cost, right? So it takes based on the throughput capacity. Throughput capacity for this size of scenario, it takes $261, and index data stored will be $382 because it's using basically there is a special price for that index data. Okay, and total per month is 644. If you see total per month, as a common generic user, you will always take the DynamoDB as your solution because it's no brainer, right? I mean, you are saving like almost threefold or fourfold, 644 versus almost 4,000. So there's a big difference. But think of this now. Think of this. The same scenario, if you see here, right? The scenario is little changed here. See, first scenario, you have 300 writes. The number of objects per month is that many, but the object size and storage, I mean, the per month, how much is the storage is different. Here, if you see, same number of writes per second, same number of objects per month, but depends on your object size. Okay, if your object size is, let's say, 32,000, which is like 32 KB basically, instead of 2 KB. Okay, and then your per month size is almost 23K, 23 terabyte, not 1 terabyte, right? It's 23 times. So if you see now, the cost suddenly changes a lot, and the solution also has to change based on that. See, in the first scenario, by default, we took DynamoDB as our solution because DynamoDB makes sense for this size of data, that object size is 2. If you are using a 2K size of objects, DynamoDB makes sense because that's supported, and that's the cost you're taking. But when it comes to the second scenario, because your object size is so big, right, your cost for index data store will be so high. Not only index data stored in DynamoDB, also the throughput capacity, right? The throughput capacity here earlier is like just $261, and index data store is 388, just in hundreds, right? Now suddenly it became in thousands. DynamoDB becomes so expensive solution now. Suddenly it became like 10,000. But whereas if you look at your S3, still same. I mean, there is not same exactly, but if you see, it is like how much? 3,932. It is like 4,500. The change is like very small. Though your size of object, only difference here, you are still using the same number of writes per second. The total objects per month is still same. But the size of objects what you are putting in the storage makes difference. So you have to be very cautious in what type of data you are putting in, and what is the size of each object, and what is the writes per second, and every factor will make a difference. This is one scenario I'm explaining, just based on the object size change, how much the change in your solution approach will be. The first scenario, by default I go for DynamoDB because that's a cheap solution for me. In the second scenario, obviously I have to go with S3. DynamoDB is not a best solution in this case because you will incur a lot of charge. Is this clear for everyone?
Yeah, Kashogara, I have questions.
Yeah, please. Yeah.
So regarding the, I know I understand your this comparison. DynamoDB, what is the index data stored? This is like index spaces further because it is storing as an objects.
No,
So
yeah,
it has to store.
basically,
What is the
yeah.
index data stored? Why that cost is? Why the shoot up for index data stored?
Not only index, if you see throughput capacity also,
Yeah, I agree.
right? So I mean,
It
because
is the underlying hardware is hardware hard disk is more disk is required.
yeah, let me explain.
More CPU usage is here.
Yeah. So when it comes to DynamoDB, how you calculate your cost for DynamoDB service is based on two factors: based on throughput capacity, based on index data stored, how much data indexed. Okay. So that is the factor, because for every service they calculate the cost differently on AWS services. In case of Amazon S3, they calculate based on how much storage, how much put list requests happening. They do that calculation. So the pricing is a little tricky. Each service they may not follow the same parameters to calculate the cost in each service. In case of DynamoDB, because they are depending on two factors: throughput capacity and index data stored, and both of them shoot up high in this scenario. Why? I mean, if your question is about what is index data stored, why they are charging for that, right? So when you store the data in object database like Dynamo NoSQL database, so to have a faster, you remember the latency is in milliseconds for DynamoDB compared to other solutions. They're very
Yeah.
fast. Why it is fast? Because you not only store your objects like object storage in the uh, HBase DynamoDB, right? And underlying, you also create index. Basically, for all your objects, you will have indexing, and that index is stored separately.
Yeah, that's why it's a
That
hardware
makes it
just like
that makes it faster. That's why it gives you latency. But that takes, yeah, if you have to index and store it separately, because it has to maintain extra storage for that.
extra storage, extra computing capacity, and
Mainly computing capacity, because indexing, once you start doing indexing for faster purpose, basically you are using additional resources on the hardware.
additional writes also because you had to write the index first, and then you had to write the actual object.
Correct. So basically it bumps up your that's why they calculate that separately. So
Okay.
and again, why it is suddenly differing between the first scenario to second scenario? Because your object size is such a big one. In the first scenario you're using 2 MB size of, right? In the next one you are using 2 KB, and in this other one you are using 32 KB. The 32 KB because you are dealing with bigger objects, so your cost is more in case of DynamoDB, because the way it operates behind the scene.
So, Kesha sir, so what if the object size is varying?
Object size is the size of data object.
No, what I mean is like, what if the size itself is varying? Like I don't exactly know what the size is. It might be like 1 KB, and then next one might be
Right.
30 KB or whatever it is. So
Definitely, yeah, that is a good question. See, generally any solution, right?
that's how most of the times it is, right? I
Yeah,
mean,
generally any solution when you design, you go with certain known parameters, certain unknown parameters, your solution design, right?
yeah,
So you have to take, basically based on the data sampling, you have to look at what is your most
max.
common denominator, and figure out what is the best size and what is the best solution from that point of view. But obviously if there are big surprises and suddenly it's like totally, because it's unstructured, I know the reason we are
That's
asking
why,
this
like
question.
exactly, if the
Yeah,
JSON like is unstructured. I mean,
yeah,
I can have like if I'm coming from the relational world,
right.
like it can have 4 columns, it can have 50 columns next one.
Correct. Yeah. So I totally agree, and that is the reason it supports. But both are supporting. But the reason why we want to be cautious when we design initially, at least not initially, it is an ongoing thing, right? Because it's a
Yeah,
cloud.
you never know. You never
You
know
never
what the
know,
next JSON is going to be.
right? You have to keep on tuning your solution changes. Again, changing from S3 to DynamoDB is not that big of a deal suddenly if you want to change. But generally, once you take some approach, right, if you know more clearly what your data is coming in and what you are going to have, you will have better control on your cost factors. Otherwise, what will happen? You can still take one of this approach randomly, right? And then go as keep on, you can set some monitors and see if the sizes are going beyond this limit, right? And you can actually literally automate a lot of processes. I don't want to keep any more DynamoDB. I want to change it to S3 storage. You can make those changes, but you have to be cautious about changing your key components in the architecture whenever, because assuming you are using DynamoDB, you might have done some things, right? And if you are switching, again, this is only, I'm talking about the storage part, not entire application, right? Just for the storage purpose, you could change, but you may still keep your DynamoDB as your interface. But where you store the data, it may not be in DynamoDB. DynamoDB can access the data from other things as well.
So essentially, as the older data, maybe yesterday's data, I push it back to the S3, for example.
Yeah. So that's what, when you think through deep, the technical architecture of any solution, slowly it will become a lot of hybrid architecture. It cannot be like a one or the other. This is the main reason, because so many parameters will change dynamically. There is nothing like a perfect solution, whatever you decide of one or the other.
Yeah.
So if I may ask a philosophical question, hopefully it is not a huge tangent for this group. If it is, please let me know. I mean, HDFS came into the existence to with the promise of leveraging everyday commodity hardware,
Right.
to do some distributed, computing and file storage and all that stuff, right?
Right.
Now it seems like it's gone. Like,
Yeah, no, it's not really gone.
Well, no way you see that, like, I have 10 computers lying in a corner. I want to bring them using HDFS and leverage some, you know what I'm saying?
That's how it started. Yeah.
It started like that. So what
Yeah,
happened,
Yeah, that's how it started, but everyone wants more and more always. So it becomes, so don't use commodity hardware. Yeah, it will work. But if you really want to perform really well, yeah, you better use the, better capacity machines. That's how it became. Yeah.
But NASA is using heavily, right? HDFS, NASA, I think primary use of defense and NASA, they use HDFS only.
Yeah. No, HDFS is still there, but his point is, HDFS started with like
why do I need to pay Amazon? Why do I need to pay anyone? HDFS came into existence to get the commodity hardware that you can buy in Best Buy or anywhere into put this to industrial use. If you want to call it that.
No, even in Amazon, you can use still. I haven't shown here comparison of HDFS. It's Amazon S3 and DynamoDB I'm showing. There is other option also here. Like you can
behind S3, most likely it is, like you said, it is HDFS. Even though
no, that's true. But as is, like HDFS itself is supported on Amazon as the Amazon EMR solution.
Okay.
That which we haven't put in the equation here. But the question is. Amazon is not throwing away HDFS solution. Actually, it is a mix of HDFS solution with Amazon S3, with DynamoDB, with all combination. So what they're suggesting is, there is no perfect bullet for you on any given solution. You may need, depends on your needs, because you are mainly going pay-as-you-go model on the cloud infrastructure. Depends on your needs, you may better go with one or the other solution as a combination. Don't use like everything always should be in HDFS, everything should be in Dynamo or S3 or like that. So they're saying you pick and choose your choices based on your needs. For example, I told you, right, reference data, all the master data, you could store it in DynamoDB. Not all the heavy transactional data, you put into HDFS.
Okay.
And any input files coming in, put it into S3. So things like that.
Okay. Thanks for entertaining my philosophical question there. Anyway.
No. That's a very good question and a very valid question. I mean, I know though HDFS started with cheap hardware to, it's still enable, but people want more and more performance and more capacity to be available for the processing. So eventually people started using, why do you use cheap hardware? Anyway, hardware is cheap. Let's use more capacity and more high profile things. And whether you are using on premise or on cloud, still the same concept. The cheap hardware versus this one still stays same. But that total cheap versus the cheap hardware or expensive hardware, that whole equation is gone with Amazon, because Amazon is providing, no one can beat that infrastructure cost, because
Yeah.
it's pay as you go.
Okay. Thank you.
Okay. Yeah. Okay, so now switching the gears here a little bit. I know we are running a little close to the time. I'm supposed to start lab at this point, maybe in another 5-10 minutes. But I'll quickly try to close some of these things, because before we start Amazon EMR as our solution, we'll deep dive into that more. The big data pipeline, generally, what exactly we need to do in big data pipeline process, right? So the data comes into your pipeline from sources. It could be any type of source, and the process wise we have to collect it, and basically whatever data comes, you have to store it, right? You might have various storage solutions based on your needs of your data, and all that access and other factors we discussed. But at the end of the day, there are 3 steps that has to happen. You should know how to collect the data, you should know how to process and analyze the data, and you should know how to visualize the data. All 3 of them interacting with storage. That's why storage play a key role. We spend some time on how to store the data, for what type of data, with various factors. Okay. Now, once you store the data, what all you need to do, how you collect and how you process, analyze, how you visualize, all the steps we are going to go one by one. Okay. Finally, end goal is you get the data, you find the insights from that. That's the goal. And time to answer. The latency, why we call it as balance of throughput and cost matters. You might want really like in a split second, you want some insights. Then you have to put that cost. And if you are cost conscious, maybe you have to make it low cost, but you can wait for 1 minute for your insight to come. Okay. This is a very standard enterprise data lake architecture that at least I have implemented in some of my projects. I just put it like a little guidance here. Again, very high level. It doesn't need to be same in all the enterprise situation, but some of the solutions that we worked, I tried to put here as my guideline. So you would have some of the structured data coming from your RDBMS existing transactional data stores, or some unstructured data coming from weblog or trade log or things like that. This is basically falls under big data category, but this is a regular data. But still, you will have all such data, which may be earlier coming into your enterprise data warehouse, either Oracle Exadata, or SAP, or Netezza, Teradata, what type of so many AWS solutions existing. It may be already going there. There is nothing you will stop. But if somebody want to move towards data lake or Hadoop environments, generally the preference is you start getting your storage original data into HDFS, or combination of S3, HDFS, NoSQL, whatever, basically Hadoop type of setup. Get into this new type of architecture, so that you will have the biggest difference between ADW and this new setup, the data lake we are calling, is this is like a data keep on streaming from your original sources, keep on coming. It's like more live data, just keep on coming and getting stored in this area. Whereas we used to collect the data into EDW and more of like a batch model, like nightly. We used to collect the same type of data, collect into the nightly, once or a couple of times into the EDW, and use it for traditional BI in the earlier days. But now the needs are growing, and the size of data is growing, type of data changing. So we changed our mechanism of storing the data, bring it into the Hadoop environments, or whatever environment it is, and then exchange your data between Hadoop environment. Instead of going to direct sources, use this as your ODS. In the olden days also, people used to call ODS, operational data store. For enterprise data warehouse, that is a need in a lot of enterprise data warehouse. Basically, our ODS, whatever is the ODS we used to call earlier, is being replaced with this Hadoop real-time data lakes nowadays. That's the biggest revolution happening right now in every organization.
But probably the only difference is ODS, none of the actual enterprise users had access to it except the
Correct.
data people.
That's correct.
No, but the data lake, everyone access.
That's
Anyone
the
can
big.
access.
That's the biggest differentiator. And ODS was there only like a backend tool for data warehouse to be
Database
processing,
people.
but now it has to be like live and operating, and should allow direct analysis and discovery on the data, live data. So that's the biggest difference you'll see. That's why all these Hadoop specific BI tools coming, and all that discovery, visualization, a lot of stuff happening on the raw data itself. And anything out of this raw data, then you summarize, you make it like all the standard denormalization, and integrate all the data pieces what you need, and make it aggregated, whatever that stuff, right? That all that still can go into EW as your regular reporting tools.
I think that's the concept you explained, ETL versus ELT,
Yeah, exactly.
right?
Yeah.
So earlier.
So really, this will be the extract part here, and extract load here. This is the part you'll do all your transformation and put into your EW. That's where the big difference now. Okay, so now connecting this back to AWS, right? So that general architecture can happen in any way. Suppose when I showed you earlier, this Hadoop solution could be Cloudera, Hortonworks, MapR, Amazon EMR, or any type of other Microsoft Azure. It could be any type of solution here. But since we are talking about Amazon and AWS solution, this is basically this process of collecting data, storing data, processing and analyzing and visualizing. In these steps, what are the type of components we are going to use, or what are relevant for us, right? Whenever you see a real-time need, you need to use Amazon Kinesis Firehose. That's the real-time streaming purpose of data collection. And data import, which is basically import export, it's called Snowball. This is mostly used for one-time data, like initial data loads. Let's say whenever you build some new data warehouse, data lake, anything, you will have like continuous feeds coming, the ongoing feeds for incremental data, but you need to bring first time all the history, whatever is available somewhere, bring it like a big huge data set, and which will take a lot of time generally when you load, collect through the regular tools, even in Amazon or anything, right? So it takes time because it has to move a lot of data over the network. So this is a solution called Snowball, where basically it's like a big hard disk. Amazon will give you like a big hard disk for you. It will ship it physically to your address for customer, and customer has to put all the data into that. It's like a hard disk, right? And then post it back to Amazon, and they will take that and load it. So that will be much faster than you transfer over the network physically. So that's the solution they use, and also for a reason of security and keeping it like a physical copy separately. So that's what one solution. And messaging queuing, which is called SQA in Amazon. Other one is Amazon EC2, which is basically regular web app servers. Like these are regular servers, right? So you use any type of mechanism to use your collecting method. And storage
So
we already talked about.
So why aren't the other popular open source like Kafka, Flume? Why don't we see that in the real time?
That's basically the real-time Amazon Kinesis is on the using the Kafka framework behind the scene. So basically, Amazon Kinesis is not like inventing something. It is basically using the everything. If you see Amazon EMR, it's not using anything special. It's behind the scene. It's using Hadoop infrastructure, basically the framework.
So they came up with their own names.
Yeah, they came up with this because basically they package it into more user-friendly and very simple to use. People don't even need to know what is Apache framework is giving and what functions they have to use and all. So simply it's like a drag and drop. A lot of stuff will be so easy for people who don't know in-depth framework libraries.
Okay.
Yeah, Nag, this is how it is. This concept is introduced by, correct me if I'm wrong, guys. So Java, James Gosling introduced this concept of frameworks in open source. He started with the application server. He started the web server and give it to the people. Then IBM, Oracle, WebLogic, and these people came up with this, new servers, basically based on the same framework. Then it can commercialize that product and sell it to the customers.
Exactly. Yeah.
They provide some good features, maybe performance-wise, and some other, basically multi-mode TLP processing and all, enterprise resource pooling and connection pooling and everything. Yeah, sorry.
Right. Yeah, I think no, that's how most of the software, right? Like you start with open source and then you start packaging them and make it easy for the developers and users and who are going to really deploy, because their intention is always just like how Amazon made the infrastructure seamless now. Like don't worry about infrastructure, network, and all all the backend things. You focus on your business and logic and things like that. Similarly, on the tools also, the HDFS is there and the Hadoop system is there, but there is a lot of things you need to know to make it enabled, to use it efficiently. So they say, don't worry about all that. We wrap it everything in nice tools and packages. So you simply use your tools like simple things. So it's the same concept. All right. So storage, I don't need to talk again. It's the same thing basically. We talked about most of the storage, object storage, real time, and RDBMS, NoSQL, search, IoT. And the process here we need to focus a little bit because this is where we are getting into. So why we are starting Amazon EMR. This is the Hadoop ecosystem, one of the way of processing data or using a Hadoop ecosystem. So where we process and analyze the data. Okay. And real time we use Lambda, Kinesis, we use a lot of this as part of real time needs. And data browsing, we use Amazon Redshift. Machine learning, we use Amazon machine learning libraries. I mean, this is again a set of machine learning libraries that are packaged by Amazon. Elasticsearch Analytics, which is by Amazon Elasticsearch. Process and move data, we use AWS data pipeline. So these are the things that we heavily focus now as we progress into our the further sessions. Okay, this is the where we will focus. And because the storage and all that we don't do much really, but just so far whatever we learned is mainly to understand all the various components. And then we will spend some time on the visualization stuff where we can use business intelligence data visualization like Amazon QuickSight, or you can use Tableau, ClickView, anything you have, right? I mean, but since it is Amazon, we can just use that as one of the option. Elasticsearch as well. So these are this is the pipeline. And mostly all these, by now, you're familiar with all these keywords, like what are all these tools and various things on AWS. But specific to Amazon EMR, this is the portfolio, particularly for big data portfolio, we will be focusing. In the space of collect, we will use one of these things. In the space of storage, we will use some of these things. In the phase of analyze, so we'll use all these things. So mostly we'll touch a lot of this stuff. And this will be a picture of like in the context of Amazon EMR in the central place, how we interact with various things. Suppose Amazon DynamoDB will be in the mix. You will be having between EMR to DynamoDB connector. You will have Redshift also here, and you will be able to interact between these two. Amazon RDS, it can interact with that. Elasticsearch, EMR with S3. Okay, EMR with Kafka here. You see this Kafka? This is where you see your streaming. So you can also use directly Kafka, but Amazon Kinesis also is like a ready-made thing. Okay, so now, so these are various Hadoop ecosystems that can run in Amazon EMR. As I told earlier, when I say Amazon EMR is one of the tool for Hadoop ecosystem to enable, it is not only just that, it can also, basically it is underlying all these things, whatever you see, MapReduce, HDFS, Spark, HBase, you're looking at all these Presto, Hive, Impala, Tej, Mahout, anything you're seeing, they're all like Apache Foundation frameworks. All these are just being used by Amazon EMR, just like any other tools, Cloudera or Hortonworks. Okay, so this is what the real ecosystem for Amazon EMR. I mean, if you go a little deep into the mechanism, right? For all the batch, mostly we use MapReduce mechanism. For interactive, we use Tej, or it could be Impala, or it could be Presto. I explained this in yesterday class, the differences between all these three. Okay, and in-memory, all in-memory type of access, use Spark. And streaming, we use Ring. So underlying, everything is run by ARN engine. Okay, that's why basically MapReduce is it's called MapReduce 2. So whenever you submit a batch job, it is using ARN engine. That means it's running by MapReduce 2. And storage is this is the difference between regular systems to Amazon. It could be S3, which is called Amazon EMR file system, or it could be HDFS. This is the difference between regular Hadoop ecosystems versus Amazon EMR ecosystem. This is the biggest difference. Other systems will only can access only HDFS as a file system, but this can leverage even S3 as a file storage system, which is very cheap compared to a lot of storage systems. And applications all live on the top layer: Hive, Pig, Spark, SQL, Streaming, ML, Ring, Mahout, Scoop, all the stuff that we are going to work with. All these are like various tools and applications that we interact to retrieve or access this data or process. And HBase, yeah.
So in the cost comparison, so what if we replace S3 with EMR/HDFS?
No, S3 is called EMRFS. That means EMR file system.
Okay, so what if we replace it? We go to HDFS.
Yeah, so you can There is nothing.
The cost change.
The cost change, of course. Your HDFS is nothing but you're putting your some EC2 cluster nodes, right? So that depends on how much storage you assign for that each EC2 instance behind the scene, right?
Okay.
So that cost will be fixed basically. So let's say I have a 100 terabyte data. If you ask me the cost wise, how much it will cost for me to store 100 terabyte data in regular EC2 instance, use it for HDFS file system, versus the same data if I put it in S3, there will be at least 10-fold difference.
Which will be cheaper?
S3.
Okay.
That's the difference. That's the biggest difference, right? So that's why people are going, even if it is a cheaper hardware you're using, it can still beat S3. But the same, if you want to use the same cheaper hardware or the same kind of whatever you can do on premise, and if you want to do that, you can still do it on the Amazon.
Yeah. Nag, the blob storage is much cheaper. Nag, basically, what they do is, if I understand correctly, in the back in old days, it doesn't store anything. Just like for relational database, you have the index and all things you have to store.
Right, exactly.
Whereas in the blob, you directly store the object as it is.
Just dump the object. Yeah,
and reading the object is up to the application.
Yeah.
Application has to unblob that object and convert into actual rows and columns. So that's why it is much cheaper from a storage perspective. Whereas if you go store the relational database, you have to write the index data separate. You have to do the actual data. Then all this typical RDBMS,
Yeah. So that's what it says, right?
For competition and everything.
Right. In the Hadoop, that is the biggest shift. Don't worry about what type of data coming and how to store initially. Just dump it in a cheapest way and quickest way. Just dump it. Then let the Hadoop ecosystems, whatever the tools, that so many tools, let them handle that. Split the data and map reduce it and process it and efficiently query it, analyze it, and all that. And if you make basically relational databases, what it is doing is trying to structure before it gets into the storage area, which is not required. That's why Amazon becoming successful. They went ahead one more step than HDFS storage. Said, okay, even if you are putting into HDFS, I mean, even HDFS is like that. You are not deciding anything before storage, but HDFS is actually doing automatically, splitting the data, map reducing, and putting into the storage, right? It is doing some process ingestion. But in S3, you don't even do that. Just dump it. Then let the HDFS or Hadoop process take care of it. Okay, so these are the kind of tools we are going to use with AWS in each stage. We're going to use Flume, Log4j, Scoop. These are type of things that we use based on batch or stream type of collection. And in the storage, we are going to use HDFS or Cassandra, Kafka, HBase, all these type of things. Process and analyze, we are going to use Hadoop, Spark, Hive, Uzi, Mahout, Presto, Pig, Impala. So we're going to touch a lot of these things. Visualization, there are a lot of tools. So far I worked with Click and Tableau in my experience, this list. But QuickSight also, is something that new. But at least in this exercise, we can explore that when we do. Now, just this is the last picture in the slides, I believe, decoupling the data bus flexibility. So if you see this, This is how typical setup in AWS environment, how we are going to set up, right? Take the data. If you see earlier, I showed you, take the data and look for the insight. How quickly you want to get the insight, that varies from your cost, right? So in between, what should happen depends on your storage needs versus your durability and reliability, scalability, all that stuff. So in between, basically, most of the time we use Kinesis as our storage initially to stream the data from sources, because we are trying to cover the spectrum of regular transactional systems to all the way IoT type of data incoming. Okay, so it can accommodate anything. That's why if you use your streaming using Amazon Kinesis as a pipeline, and which can put the data into EMR where you can process data and then shift the move the data, whatever, like reference data or master data type of things, into DynamoDB, and keep the other things into S3 storage as like your HDFS. In case of here, you have a choice: put your all your heavy, high volume data, transactional data, either in EMR HDFS itself, or put that into S3. But EMR can still access that files. Okay, and the other path, Amazon Kinesis 3 connector, it can directly put this data and put it into Amazon S3. That is another approach. And then use that as your starting point to split the data and put it into EMR or whatever, right? And from DynamoDB or S3, this bucket, the storage area, you move the data that is required for your data warehousing purpose, the Redshift and all. And then you build your quick site either on Redshift, or you can actually do your QuickSight directly on any of the EMR environment as well. But they prefer QuickSight there because Amazon Redshift is already, it can handle like huge volumes of data, and they say all your analysis try to do from there. That's the recommended way, but there is no hard and fast rule. You can always use anywhere. That's it. This we already talked about, and what is DynamoDB and HDFS here. Maybe I want to take a look at this once. HDFS local disk, great performance, storage optimized, instance provide ample disk space, data is local, not streamed from Amazon S3, can copy data to Amazon S3 as needed, data is lost when cluster terminated. This is the biggest difference. I think Nag, you were asking this earlier. One of the biggest difference between S3 and HDFS. HDFS, if you use your own instance and storage. Whenever your cluster, let's say we have hundreds of nodes, right? Whenever you terminate your cluster, any node, you basically lose the data. But when you put in S3, there is no such concept.
Because they duplicate, right?
Yeah, they already indirectly that's what happening, right?
Yeah.
But it's seamless for us. But we keep it in S3; it's always there, 99.999%, whatever that percentage, right? But in case of HDFS, it's your duty. Like whenever you terminate, the data is gone. You should be aware of it, and you should, add additional nodes or bring up, bring down, whatever you need to manage yourself.
Yeah.
Okay. And run queries against unstructured data using processing framework, high peak Spark and all that. So yeah, so these are some of the standard things. Direct integration with Amazon EMR, that's the advantage here. S3 can also be used as no need to add HDFS nodes to increase space throughput. And yeah, these are some benefits basically using S3. There is no rule that you should use S3, but recommendation is, see, this is the recommendation. Aggregate all data into S3 as much as possible, because you are on Amazon environment, which is S3 is a very cost efficient and more durable, reliable storage. So they suggest to do that, and have your ecosystem like EMR, Kinesis, data pipeline, and have your Redshift and DynamoDB, RDS, all type of needs you have, and use it for based on what you need. But keep your data in S3, and whenever it become old, you keep it into Glacier, much more cheaper. That's what they suggest. Why is Amazon S3 is good for big data? Yeah, this might give a quick snapshot of that. Natively supported by big data frameworks, Spark, Hive, Presto, can be used as storage for Hadoop clusters. Amazon EC2 Spot instances, you can use for anything. Unlimited number of objects, very high bandwidth, high available. See the durability, 99.99999% durable. That you can never lose it, data. tier storage, standard, and frequent access glacier. This is based on cold, hot, and all that life cycle. Low cost, especially for large volumes. That's it. And this is a final view if you want to see how it should be or design. HDFS, basically your Amazon EMR based on HDFS setup, and the HDFS could be configured to use Amazon S3 bucket directly instead of using EC2 instances and all that regular storage. And your Amazon DynamoDB also can be interacted with your Amazon EMR ecosystem. So that's it. I think now I will couple of questions. I will just try to quickly catch up here to make sure you all understand what I said, and then we will jump on to lab. And I know we are late on the lab, but I'm confident that lab should not be a worried thing because you always can finish this even on a later time after the class or tomorrow morning. So this one, can anyone tell these 3 questions, simple questions? I'll leave it that. List 2 reasons to choose DynamoDB to store data. Any thoughts?
Speed and price, latency and price.
Latency and price. And I mean, price again, it's debatable, but definitely if you want to use high latency, DynamoDB is the one. And another reason wherever you have
low latency, right?
Sorry, yeah, low latency. Yeah, low latency is the one definite reason, and there are other reasons actually. Other important reason, whenever you have a need to store kind of like some structured or non-structured, you don't know what type of data you're going to store, it can actually support both. And yeah, mostly for like a small data sets, like reference data sets and all that, you use it. It's more, you consider like a database, transactional database in a Hadoop ecosystem. Okay, order these services by lowest to highest latency. So yeah, this is an interesting question. Any thoughts on this?
For me, DynamoDB.
Remember to turn on
No, DynamoDB lowest to high latency.
Lowest
DynamoDB,
to yep.
DynamoDB, Amazon Redshift, Amazon S3, Amazon Glacier.
I think Amazon S3 and Redshift is
different.
Yeah.
I see.
It has to be DynamoDB, Amazon S3, then Redshift, then Glacier.
Okay. Yes,
and which of the following data storage options is best for highly structured data? That's a good question too. Yeah.
RDS.
That's it. On the spot. That's good. So that's what as long as you know the differences of what solutions we are trying to do, then that will be, because when you are doing, mostly you need to be considering all these factors here. That's all. So here, let's see what the answers are really. I mean, that's what we said is a DynamoDB. Oh, actually, he's right. Redshift is low latency compared to S3. Oh, okay, because of HTTP network. See, when you keep the data in S3, you're actually getting or putting the data using HTTP over HTTP request. So that's the difference. Even if it is within the ecosystem, it has to go over the HTTP request. That's the difference, I think. Yeah, that makes sense. And the first one is working with data with no schema. Whenever you don't have schema and high compatibility you need, those are, I mean, there are a lot of factors, but those are the 2 he gave. And yeah, this is Amazon RDS. That's it. I think, yeah, the next session we will start tomorrow, but let me bring up the lab that we have to work on. The lab that we have something called Introduction to Amazon EMR, I believe. Yeah, Introduction to Amazon EMR. So you can go to the same thing, Amazon Labs. Okay, when you come here, you search for the lab. Actually, go to the catalog always. Okay, from there you search. Go to catalog, go to labs, and search for a lab called Introduction to Amazon EMR. You'll see something called Introduction to Amazon Elastic MapReduce. Yeah, looks like this has 1 credit. So if any of you don't have credits currently, I think this is the time you may need to add credits in your profile. I'll show you how to add. Go to your My Account actually here. You see on the right hand side, you see this icon.
Yeah, profile icon.
Click on that and you say buy credits. So it'll ask you right now I have 0, right? Let me add mine by creditor. So basically you should be able to add this on your own. See here, you will see labs typically cost 0 to 15 credits. Minimum purchase 5 credits. So yeah, you cannot buy less than 5. So anyway, we need for other classes also. I would prefer my suggestion. I mean, they are saying advantage subscription is $55, something they're giving. I mean, we don't use definitely more than 20 or 30. So I would prefer 40 credits with 5% discount, $38. That is reasonable. But if you want to really do a lot more after the training session and you think that you're going to use more and more, having some extra is not a problem. Like then you can go for advantage subscription. That's 55 default. So again, it's up to you. It depends on whatever you're comfortable. I would suggest to take that one. I will take 55 because at least I wanted to use some of these things further.
But how many credits for the advanced subscription?
No, that's what 55 means 55 credits. But obviously, no, it will be more than that. Sorry, advantage because they are giving. Suppose for 40 credits, you're charging 38, so 5% discount, right? So now for 55, let me see. I'll do that right now. You can see that total 54.99. Let me do that. Pay with credit card.
Oh my God, the commercializing every aspect of it.
Too much. Yeah, I know. Yeah, they do that because this is all like because it's like again on cloud, right? So everything is like depends on how much you use the capacities.
Yeah.
Okay. Okay. So let me see here.
No, it's vanity. We don't want.
Yeah, I think basically process-wise, it's very easy. You'll see your credits once you see. I didn't mention. I'm trying to see how many credits are given. Let me go back again. Maybe it will show. Yeah.
It says unlimited for 1 month.
It's $55 per month.
Okay. That's why it is. Yeah, that's actually better than if you want to rigorously practice more, right?
Yeah, become a AWS big data architect.
Yeah. No, actually, because at least if you for a couple of weeks anyway, we are going to use, and if you plan to use additional labs, and there are a lot of labs really available. That's really good because that actually gives you to learn some advanced things also. So though I'm covering like some important things that you need to know for the fundamental and basic things, but eventually, one more thing, important thing I wanted to let you know. Once we are done with these training sessions, we are also going to sign up our free account. Amazon AWS, everyone get 1 year free account, and with all the services, a lot of services free, all the basic services, and except few, and from after 1 year onwards, it will start charging for some of the services we use. So everyone make sure we all have our own account, but don't do now, because you don't, for labs and all, this is most suitable. But once you are done, then regular AWS, Amazon, if you sign up for free account, you'll get 1 year free services on all the services we are going to have, including some storage and some basic. And if you need more storage, obviously you have to pay, but limited to some extent, it is free. I didn't remember exactly all the limits. Okay, so search for this, and once you have this, let me open. So this is a 50-minute. I don't think you can finish it now, but you have. I mean, are you guys getting some time in the evening, sometime like after coming from office or in the daytime? You know, some of you, I think you can do it off in the daytime, but maybe for home and few other people, I'm sure you'll not have any time left. You're coming from New York, right?
No, I'm trying in the afternoon. I want to try afternoon or during the lunchtime. I'm skipping the lunch. And
none of the exercise will take more than 1 hour, but whenever you get time during the day, definitely please make some time. And I'm sure there is, if any issues also, let me know. But 90% I never faced any problem. Some of these already I did multiple times, and I never seen any big issue, because the instructions are very clear, until unless you really stuck with any technical issues. But it should be like very straightforward what we're trying to achieve in this. Okay, in this case, we are creating an Amazon S3 bucket, and then creating and launching a MapReduce cluster. That's an important piece. And then we are here, if you see, we are keeping our S3 location as input location for the EMR. And what else we're doing here, the key things. And monitor the cluster, view the results. Yeah, basically this is like a basic setup of how you do your Amazon EMR cluster. Okay, and again, you don't do really much other than configuring some things, but don't think that is a simple thing. If you have instructions like this, you are doing right. When you don't have instructions, if you have to go to a client place and you need to set up your own, and those parameters may not be the same exactly what they need for their requirements. So you need to be digesting and understanding whatever you are doing here, what parameters or configurations you are doing, and why are you doing. And if you know that, then you have a proper justification when you go to a client place and you are doing your own environment setup or doing your own things. You will have a clarity of what is best for your setup. That's what you are learning really.
Here, yeah, sorry, you're done. After you're done.
Yeah, no, I'm just trying to say, labs are going to help you how to do by instruction based right now, but it doesn't mean that will be enough for you. That's why I'm covering anything that I talk generally through my presentations and all that I'm doing, to let you know what type of variations you have to think through to decide some of these configurations.
Yeah.
Okay. Yeah.
So coming back to this creating a launcher map cluster is nothing but it's a redundant node, right? It's a node list of physical CPUs, right? Physical machines, which are physical.
Yeah. Launching cluster means, yeah, in this case, what happening? Usually, if you have to think of like a physical environment on premise, right? If I have to build a cluster for Hadoop, let's say I want to create 100 node Hadoop cluster, right? So imagine the steps you have to take to set up your 100 node cluster on premise. Okay, what are the things you have to do? Assume that you're not Amazon, or you're not using AWS platform, or you're not using Amazon EMR. If you think of the number of activities you have to do and the time it will take for you to bring up your cluster, first of all, you have to procure 100 physical cheap hardware, whatever it is, right? And one master node for one big good machine at least, right? And once you procure that, you are basically going to have, those are physical hardware boxes, but then you have to set up first your operating system, Linux or whatever version you want on all of them, right? And then you have to install the Hadoop, HDFS, whatever the Clouder or any whatever platform you choose, you have to deploy that software, right? Install the software, and then start actually doing the configuration required for its setup. So if you think of setting up such things on that many number of machines, right, to make it enabled for your cluster, and then you maintain your cluster management from there, administration or whatever, right, with the master node. So the time it takes and the launching cluster, it takes at least several hours or days, right, to make your environment up and running.
No, imagine if you order the hardware, procurement has to go. JP Morgan, it will take at least 6 to 8 months.
That is another thing, right? So today you get your thought into mind that, okay, I want to bring up my Hadoop cluster. So first, yeah, the procurement process itself is like weeks or months for sure. So from there, you are coming to nowhere. Today you decide, your thought comes into your mind, you get onto Amazon EMR, Amazon AWS, in a few minutes or seconds, your cluster is up and running with whatever configurations you want, and with much less, tenfold less cost than what you would incur for your cluster. So that's the biggest benefit of this one. So the cluster, I mean, again, what it is really doing, for the question originally you're asking, replication, right? So when cluster means like why we are having so many nodes, I explained in the yesterday class. I don't know you got chance, but that would give a very good clarity. I mean, for people, others, they should be having some idea now by now, but you missed the class yesterday, so I want to share that again, that one particular slide to make you understand what it means. This is exactly need to understand how the HDFS works, the master nodes and data nodes. Okay, if one block of information comes, it's going to automatically split into, like, depends on number of nodes, right? So I have 4 nodes, it's splitting into 4 nodes, 4 pieces, right? And what it is doing is it's taking the first block of that information, putting into first data node, okay, and not only putting there, and also it is replicating to other 2 at least, because it's see, data replication factor here is 3-fold by default. If I have 4 nodes, I am making my data replication factor as 3-fold. I can make as I wish. I can make 2 or 4 or whatever, depends on number of nodes, right? So what you are making, basically you are making your every block of data, not the entire piece of data. The block of data, what comes, you are splitting into multiple blocks, and blocks of information you are storing. For every block there is one primary node, data node, and it is replicating to other nodes, and based on our configuration. And then what it is really helping is, at any point of time, you have your information is available in more than one of the data node, and when the process, basically name node will keep tracking your job. Let's say I send one query to the name node and say, okay, I need to get this data, and name node will maintain a job tracker and tells, okay, to get this data, I need to create some tasks and assign those tasks to all these data nodes, and it will give the same task for all these data nodes, but whoever comes first, it will pick up that, and each data node will be able to process the task with the data what they have, not only the data they have. Suppose data node 1 doesn't have a block 2, it has 1, 3, 4. As soon as the task comes to this, it will try to pick up the required data. It knows what is required to do this task. It needs 1, 2, 3, 4, and it will find already 1, 3, 4 here. It will just go back to another node to get the 2, one of this node, and whatever comes first it will pick up that, and it will form the task tracker will fix whatever required and send it back to the name node. Job tracker will finish the job, and because it produced so many other tasks already, all that will be automatically killed once, because you are giving so many multiple tasks to multiple data nodes to make it what can come fast with redundancy. Okay, and this will make sure you never lose the data. Even if one node went down, you will never have data loss because other 3 nodes can survive. And while you are working your process, maybe still you can bring back another node in that place, and that will automatically start reflecting into that. So the replication factor in general, you might have Oracle Golden Gate replication or some other replications already in the database world, but that's only replicating to one server to server, like big data sets. But the replication we are talking here is at the block level. At the, let's say if I have a name, right, like a first name, last name, right? Finally, it go and sit in like a bits and bytes, right? The data. So it's going to split the data into like 64 bytes or 128 bytes, like that size of blocks, and replicate them across the data nodes.
No, here is one example. Employee class, employee object is there, which has a first name, last name, age, department, salary, location, and how does it sound? Now it is a block, one object. I'm trying to write 3 objects.
No, that is an object. That is not a block. Let me put it here clearly. When I say block,
no, let me read it. I don't want to waste your time. Sorry, others don't want to bother other people. Let me read your voice. I will read tomorrow.
Yeah, no. Can you see this here a little bit once?
Yeah.
Whenever the data comes, right? Files. You give me a file which might have, like, let's say 100 records, right? Each record might have 20 attributes, 30 attributes, whatever, right? I am not taking each row wise here. I'm taking the entire file data and splitting that whole data into blocks. Usually, like, it's a 64 MB or 128 MB size block. Okay, I'm splitting the entire file as certain blocks, and I'm organizing the data, storing and organizing the data into thousands of nodes on my cluster nodes, and my cluster mechanism know what data stored where and how to access it and how to process it as the request comes. So this is not a regular replication of a file coming and replicate in the regular case, right? In the database or any files replication or anything, that whole file will come and replicate into 100 different servers.
Yeah.
You see the difference?
Yeah, I know. I see. This is interesting. I didn't know that.
Yeah,
I hear that.
It's not by, like, this employee,
No.
address is stored in one, and it's not like that.
No, I hear that. For someone, I gave an example. Employee name. So employee has a 5 attributes. In our case, first name, last name, email address, department, salary, and whatever this one. So it is stored the first 2 address, first employee, first name, last name, the data node 1, and age and department in a node 2.
Yeah, that's not the case.
Yeah.
I'm curious. So
yeah, that's why yesterday's topic really. Unfortunately, you missed it yesterday because
I'll go through their file.
But this is really a key topic actually yesterday what we talked, because how the mechanics of the HDFS and file system, even the MapReduce, how this MapReduce works.
Yeah, here I was just going back to something on the AWS slides earlier. You said if one of the node is gone, data is gone.
That is no, that is only in case of regular cluster nodes. Data is gone means, let me correlate to that point, right? When I say data is gone, in the scenario that we just talked earlier here, right? Let's say one of the data node is gone. My 142 on this data node is gone. That's all.
It doesn't mean one from somewhere else, right?
Yeah,
in the other node.
It doesn't mean that you lost the data overall, because you still have a lot of nodes. But the difference, even this data node, whatever it is lost, if you take S3, even that is not lost, never lost. That's the difference.
But here, to me, if I'm following this one here, let's say the bottom node is gone. It is still seamless for me, the end user, because it is creating multiple tasks anyway.
Right. Yeah, it is seamless. But the important thing to know, I mean, when you store some data on any storage system, right? though it is seamless for you and it can manage automatically, even if one node is gone, but you still have a responsibility of bringing up another node whenever that is terminated or something happened to that node.
Yeah.
Right. But in case of S3, I never need to worry about that.
Yep. Okay.
Oh, this is the only issue with HDFS you're saying, right?
You know,
If you use S3, it's not a
HDFS, yeah,
problem?
in case of HDFS, usually it goes by cluster of nodes, data nodes. And if you designed your cluster nodes to be like 100 nodes, for example, for your capacity needs, right?
Yeah.
And it could be scalable, right? Again, you decide 100, but then you could go to 200, 300, depends on your needs, and you can reduce. All that you can manage. But when you decided to be 100 and you want to keep it static for, let's say, for 6 months, right? And during this period, for some reason, one data node gone for some reason, because it's cheap hardware or whatever, right?
Yeah.
Something gone. You still don't lose the data really, because it's seamless for you, because it's replicated into multiple nodes, and you can always, it's always going to work for perfectly. But still, for the reason of keeping it stable, your environment, you still need to make sure your 100 nodes are up and running anytime, right? Just because one or two lost, you cannot keep quiet. You have to, right?
Yeah.
So, but in case of S3, you will never really worry about that scenario.
No, I agree. S3 is durable and everything.
Durability, yeah. Because once you put the file there, there is no concept of losing it or maintaining the nodes for that.
But here, in this case, if I lost the last 3 nodes, I'm gone. But 2 is not there at all.
Yeah, that's exactly. That is why, I mean, this example is a simple 4 node and keeping. If I have hundreds of nodes, my data is in at least 50 other things, right? So, and your durability, your replication factor will not be threefold. If you're having 100 nodes, you might put like your replication to, 50 of them, whatever, right?
Yeah.
So, but problem is, you can never keep quiet when there is something happened to your node, abrupt or something happened. You have to still replace that and make it available. Otherwise, what if another thing gone, like you will be having problems. So you have to maintain your environment stable.
I agree, but if the entire cluster is gone, entire cluster of 100 nodes are gone, where do I lost the entire data, right?
Yeah, that's it. That is another thing. So imagine Amazon, why Amazon is selling so greatly about their products. There is always a chance of, though it is a less chance of having all the 100 nodes going away, right? Still, as long as you're on premise, that's the first risk. Your hardware could fail anytime and you would lose everything if possible on one night, right? But you put it on cloud. First of all, cloud itself will give you a lot of assurance. If you put it on SC2, same on-premise infrastructure, data nodes, you put the same cluster on the AWS cloud without Amazon EMR or S3, right? Still, it is somewhat reliable for you because it's cloud. Your storage is not gone. First of all, crashing your server or something gone is not very less chances to happen. Your EC2 instance will be always stable. But if some abrupt situation happen, even in the cloud environment, again, compared to S3, S3 will never lose because they are taking care of all the additional replication, whatever required for the data center or for that storage, without cost for us. That is the guarantee they are giving it to us.
Hey, one thing, but Kesugaru, this case, even if we lost all the nodes, this data is coming from the file system, some file, big file or this one. We can always restore back that file and put into the clusters, right?
No. When you say file system, where is that file system? It is on your data node.
No, the actual file. That is, suppose 1 terabyte, 10 terabyte data, the file is coming from the actual data is coming from file, right? File or some kind of source.
Oh, original source. I mean, you cannot. Yeah.
How can you trace it back if it's a transactional thing? Like let's say, then you don't get it.
No. I have the 1 terabyte of HDF file, and I want to put into the different nodes. This is for calculating, doing the searching and other generating analytics. I have the original file, source file is there already, right?
Well, this is meant to be your original, whatever it is. So
no.
Because see, well, let me clarify one thing.
How this guy is
no, remember, this is the data lake.
Okay.
Yeah, no. One point to clarify. This is we are talking about huge data sets that is keeping all the history into data lake. There is no other place you can keep that data.
This is the master.
Which is the master. So it's a collection of all your enterprise data for all the history.
So I'm sure they probably S3 probably has a copy or a replication for each data node in the backend, and that's how they probably are guaranteeing.
They're guaranteeing.
If I'm maintaining my own hardware in my on-premise, then I probably have to build, the old-fashioned copy replicates for each data node.
Exactly, because S3, the advantage of S3, right? If you see, it is not the way they are giving that 99.999 and the durability, not just because they're replicating to multiple servers. They're actually replicating to multiple data centers across the regions.
Yeah.
And because even if one entire data center is gone, even behind the scene, right, Amazon has to have some data center and maintain somewhere physically. But what if some data center itself is collapsed, bomb, something, right? But then still they have replicated into various regions and they can bring it back just like that in seconds.
No, I agree. But my question here is, see, I don't have these clusters are empty. Just now I install all these clusters, hardware machines. The cluster, I set up the cluster. Now I need to put the data into this the cluster, right? The cluster nodes. So the data is coming from the JP Morgan is sending all this data to me.
Okay.
So they're giving the file. They're not giving in the Hadoop cluster. They're giving as a big file.
Yeah, where do you put that?
Chunk of files.
No,
let me tell you. I put all those files into the S3. Then I give the S3 to I write using the Hadoop system. I read from S3, put it into this data node.
Okay. You delete from S3 or no?
No. The master copy is stored in the S3 always.
Yeah, then that is what exactly Amazon suggests. You put it in S3 first, keep it as your safe zone, and then use your HDFS or whatever you want, Redshift or NoSQL database, anything to further do anything with that. Always keep your master copy and the total as a central storage as S3 mainly. That's what they say.
Yeah, that's
but
what I'm saying.
You don't have that option in the regular HDFS environment.
Yeah, I agree.
That's exactly Amazon is making point on making money on it. Yeah, I think I mean there is a reason why it becomes so successful.
Everyone is asking maybe other people have questions.
Yeah. So just bring up any other questions. These are all interesting things to discuss, and I'm sure this will be the one you will not get outside anywhere. I'm sure people like all these experienced people here, like these topics really are very useful for your knowledge. Okay. All right, then I mean then just continue with the lab and let me know if any issues or anything. So I mean, if any issues with the lab particularly, maybe let's take the approach like this, right? I mean, almost every day it's getting like that. We are coming to the end of time, but if we cannot finish the lab in the same day, try to finish on the following day, and we can discuss when we start the class. We can discuss about any issues or anything. If no issues, we can continue with the process. Okay, because I want you to cover a lot of these topics, which is very important as well, along with the labs you're doing. The labs mainly helps you to make your hands dirty to feel what is actually this environment is, and but you have to correlate with always the information we are talking. Any other questions from anyone?
Regarding the lab, what should we see? Can you go to the lab exercise that
sure? Yeah.
Seeing that we are not doing anything, just creating the lab and a console and a cluster and then view the results. What exactly view the results?
No, basically this is to explore the environment. Suppose if you don't know how to create Amazon EMR currently, you know AWS, it is there, but how to know how to create and what it will do, what type of parameters you have to set. This is basically you have to make your hands dirty a little bit to just to get familiar.
I agree. Okay.
Yeah, without this,
really exercising, we are not really doing any actual exercises.
Yeah, because what happens, I want us to be in a place, given a requirement from a client or anyone, right? We should be able to think on our own and create just simply going to Amazon directly, right? And look at all the services, and I should be able to pick and choose what I need for my setup and do my project. But you can be there in that situation only if you make yourself familiar with all these tools and with the little labs practice. That's why when I ask me assignment also, like anything project we'll definitely take, but first you have to get some hands on to this little bit.
You got it. Thank you.
Okay. Yeah.
I think we can end. A lot of people left already.
Yeah, I think this lab purpose is, if you want to know what exactly we're doing, we are creating how to create Amazon S3 bucket, and how to use that when we launch Amazon EMR cluster using a console, and then run the word count sample application to process the data, and then monitor cluster by viewing the Amazon EMR console status indicators, and view the Amazon EMR output data in the S3 bucket. So this is what we are achieving. I mean, this is just an example. Tomorrow in your project, if you have a need to do some data processing using Amazon EMR and put the output files into S3 bucket, right?
Yeah.
And you don't need to go through these instructions. You can do your own, but you need to know how to do that. That's all. So all these are like building blocks. We are creating one by one, and then we should be able to plug in all these things to do this type of similar steps for doing our project.
Yeah, thank you.
Okay. All right. I think if everyone leaving, I think only Nagesh. Yeah, Dheeraj?
So actually, you compare the cost, right, between the S3 and DynamoDB. So is there any tools in the real time to compare the cost before we going to opt something?
Yes, there is on Amazon website. There is something called calculator. What is it? Cost calculator on the Amazon website. When you go to AWS services, there is one. I'll show that somewhere. So basically that will, before even you design anything, you can actually calculate everything upfront based on your inputs.
And based upon like what we are expecting to be the object size or something.
Everything, it will ask all the parameters. If you provide all the inputs, it will give you cost comparisons, and that's a nice tool already developed. I have it here. Let me see. It should be here in. Actually, if you just Google it, also you'll get it. Amazon.
Yeah, it's fine. And I just want to know, like, how do we go with just our intervention, or we got any calculation?
Yeah, that's how people do. There is a calculator before even anybody do. That's what they do. AWS cost.
The call, okay.
Yeah. Okay, sir. Yeah. Yeah. Here it is. Estimate your costs. AWS simple monthly calculator.
Kesha garandi. Good night, Andy.
All right, sir. Yeah. Good night.
Bye.
Yeah.
Yeah. Good night. Good night, Kesha.
Yeah. Good night, all. I think we are running late, so let's stop here. But definitely complete your exercise before coming to tomorrow class, and ask me if any questions or any roadblocks or any issues. Okay.
Yeah. Thank you.
Thank you all. Yeah. Take care. Good night.